Alright, looking at student.desmos.com, and the code is UZGCPA. I'm going to take up one of the questions. A water wheel with a radius of 3 meters, whose center is at water level, and that rotates once every 15 seconds. So I want to be able to draw a periodic or a sinusoidal function that will represent that. Okay, so I have a picture of the water wheel over here, and just to give you an idea of what that is. So it has a radius of 3, so from the center to the top is 3, from the center to the bottom is 3. So I've kind of aligned it here, and I'm going to put the center line of this along 0. So then the radius will extend 3 meters above and 3 meters below. So that will be the range of my function. So my entire sinusoidal function will happen between positive 3 and negative 3. Okay, so we're looking at seconds, so as it's turning as the seconds are going, and we're going to see how high it is above or below the water. So this is the height along this axis, above or below the water, given that the water is at line 0. And then the other axis is time. Okay, so let's assume that we're starting at the top of the wheel and it's going to go around. So the top would be the maximum, so at time 0 we have a maximum of 3. It says that it circles every 15 seconds, so the next time we hit a maximum, will it be at 15 seconds? The minimum will be halfway between the maximum and the minimum, and the two maximums that I have there. So halfway between would be 7.5. So at 7.5, I will have a minimum at negative 3. Continuing with this logic, every 15 seconds I'm going to have a maximum. So I have the 0, the 15, I'll have a maximum at 30 and a maximum at 45. And then looking at the halfway points, I'll be able to get the minimum. So halfway between 15 and 30 is 22.5 for a minimum, and halfway between 30 and 45 would be 37.5. And then I can just join those points to make my curve. So joining all the min and max, I get the yellow curve that you see above.